So, in our first project, we launched a projectile up into the air and let it fall. Now, using this diagram, we could find out what we know and what we need to know. So, we don't know the total distance in which the marble went up into the air and went down. The displacement would be 0, but we don't know the maximum distance that it went up vertically into the air. We also don't know the initial velocity and final velocity. What we do know is that the total time that it took was 0.96 seconds, and that at the very top, before the ball went down, the velocity was 0 meters per second. Now, we could use the first formula, which is acceleration equals velocity final minus velocity initial over time, right here, to find out velocity initial. Now here's how we do this. Essentially, what we're making right now, if we were to draw the whole progress of the ball, it's basically a parabola, more or less. Now, if we were to cut that parabola in half and say we're gonna find out only the initial velocity and the time it took for it to go from starting to 0, where there was no velocity at all, that's basically half the time. So now it went from 0.96 seconds to 0.48 seconds. Right now, 0.48. And that would be the same for going down as well, just not only just up. So if we were to put it back into our equation, it would be A equals velocity final, which is now 0, minus velocity initial, which is 0.48, equals acceleration. Now, we already know the acceleration due to gravity is negative 9.8. So now we could plug that in for A, which is acceleration, negative 9.8. And we got every variable except for the initial velocity. Now, we could use some basic algebra and find out that negative 9.8 times 0.48 seconds equals negative initial velocity, right here. Now, if we were to multiply what we already have and multiply the result by -1 to get a positive initial velocity, because we're trying to isolate the initial velocity variable, we would get 4.704 as the initial velocity. Now, the reason why I'm not using sig figs right now is just to be as precise as possible. And this is probably the only time in which I can do that, given permission by my teacher. Finding when the ball is at its maximum height, which would be when velocity is 0. So initial velocity would be 4.704, and final velocity in this instance would be 0. And 0 would be final velocity. And if we were to plug it into the equation of A equals v final velocity squared minus initial velocity squared divided by 2d, and plug in all the variables that we know. We don't know what d is yet, so we know that acceleration is negative 9.8. Negative 9.8. We do know that final velocity in this instance is 0. So 0 squared is 0. Now, 4.704 squared, if I remember correctly, is a very ugly number. That is for sure. Let me check it in my calculator and we will go on from there. 4.704 squared is 22.127616, yada yada yada. It's a very ugly number. So let's just simplify it and just say 4.704 squared. And we'll just put that in brackets. Over 2d. So this is what we have so far. This. Hope you can see it. And then, using simple algebra, we're going to isolate the variable again. We're going to multiply both sides by 2d, so we can cancel out the fraction on the right. So now we have negative 9.8 times 2d equals negative 4.704 squared. This is what we have. Now, we had to isolate d because we're searching for the maximum distance. We're looking for the maximum distance. So why don't we divide both sides by the product of negative 9.8 and 2 for both sides to cancel out the negative 9.8 and 2 that are in coalition with d to isolate d. Then we're gonna get d equals negative 4.704 squared divided by negative 19.6 as is shown, and plug it into our handy dandy calculator. We're gonna get d equals 1.12896. But if we were going to use sig figs, because the largest number, the smallest significant figure is 2, because it only has one significant figure, it would be, d would be around 1 meter, which is equivalent of 3 feet. That's pretty cool. All right, now we know the initial velocity. Now we can go find the final velocity using the same rule. But now, instead of using half the time, we could use the full amount of time it took for the ball to go up into the air and down to the ground. Now, here's how we do this. So we take off, instead of using half the time and using zero as final velocity, because we were only using half the time, and half the time meant that the ball was in a state of no motion whatsoever, we could replace final velocity with the variable v of f, and we could take out the variable initial velocity with the actual number, which is 4.704, and that is all divided by 0.96 to equal negative 9.8, which is the acceleration of gravity on Earth, because that's where we live. So now, doing some more math, we could find out using algebra to isolate the value of final velocity. All you had to do would be to multiply 9.8 by 0.96 to get rid of the fraction on this side. Now you have a negative 4.704 still with the variable. So in brackets you would multiply negative 9.8 by 0.96 and you would get negative 9.408 plus the 4.704 because we carried that number to the other side to isolate the final velocity. Now that's going to equal b of f right now. So this is what we're getting right now. I hope you can see this. So this is what we're using right now. Now if we were to plug it into our handy dandy calculator, we would get that negative 4.704. Whoa. We have the same initial velocity and we have the same final velocity. That is crazy. So we have negative 4.704 as our final velocity, and we have positive 4.704 as our initial velocity. So we found both of our velocities. Now we could plug these two velocities into another formula to find the distance, because we don't know the maximum distance, and we only need the initial velocity for this because we could do it both ways, but I find it easier just to use the initial velocity and finding when the ball is at. For our second project, we're discussing about horizontal projectiles, which is basically projectiles that are launched horizontally with no initial velocity, only a final velocity and a horizontal velocity. So we used our slingshot to launch a marble, and this is me standing up, launching my marble as flat as I can be. No angle is used. We had to make sure that this is basically like going as straight as possible, then gravity just starts taking more and more of effect, and boom, we have a final velocity. Now, what we do know is the distance that it took between the ball hitting the floor and me launching it, which would be 3 meters. So this is the y displacement. And we know the time that it took between me projecting the marble and the marble hitting the floor. What we don't know is the final velocity, the horizontal velocity, and we don't know the vertical distance in which the projectile was launched. Yet again, don't worry, we're gonna have to solve for D, but let's find a way to do it easier. So if we were to times both sides by D, you would get negative 19.6 D equals negative 5.096 squared. .6 squared. Boom. Now, divide both sides by negative 19.6 to isolate the variable of vertical distance. And what do you get? I wonder. Negative 19.6. Plug that into your calculator. And you, my friends, will get an answer similar to 9.6 squared divided by negative 19.6, negative 1.32496, yada yada yada. So all in all, you would find out that the distance, the vertical distance in which I shot at, would be around 4 feet, which would be increased crazily accurate because I shot it at my shoulders. And I'm only 5'4". So D equals 1.32496. Using sig figs, we would just put it simply 1.3 meters. Now, we found all of our variables. We could solve one of our variables, which is the horizontal acceleration, by using the formula horizontal acceleration equals horizontal distance over time. Now, plug in the numbers, and it would be 3 divided by 0.52, and you would get a nasty number, which would be similar to 5.7, yada 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 yada. But using sig figs, we would only have to use one number, and it would be, rounding up, 6 meters per second horizontally in the x direction. Now, we found our horizontal acceleration. Now let's find our final velocity. We could use the formula acceleration equals final velocity minus initial velocity over time. We actually know 3 of these variables. We know acceleration due to gravity, we know the total time, and we know that velocity initial doesn't exist because we're only shooting the projectile horizontally. So there is 0 in place of velocity initial. So let's plug that all in. .52. And if you didn't already know, acceleration due to gravity is negative 9.8. Now we get this. Now we have to isolate the variable, which is the final velocity, times both sides by 0.52. Then you would get negative 5.096 as the final velocity. So we got another one of our variables down. Let's check for our velocity final. Now we could find our distance. We could find at what height did I shoot the projectile by using the formula that's similar to it. Acceleration due to gravity is equal to velocity final squared minus velocity initial squared over 2d. Simple, sweet. Now, we could plug in the variables that we do know. We already know that velocity initial is 0, so 0 squared is 0. We know what velocity final is, so it would be negative 5.096 squared. So we're going to get a positive number on top, divided by 2d equals negative 9.8. This is what we have so far. Times both sides by 2d to isolate the final velocity yet again.
This is the angle. Okay, ready?
Yeah. So for our last project, my partner and I decided to launch a projectile at an angle through a slingshot mechanism and find out the distance between the launching point and the landing point of the projectile and how much time it took in between. Now, what we had to find is the horizontal velocity, the initial velocity, the final velocity, the vertical distance, the maximum vertical distance, and we need to find the actual initial velocity. We could find horizontal velocity by using the equation v of x equals d of x over t. Horizontal velocity equals horizontal distance over time. Plug in the numbers. The horizontal distance is 9 meters. The total time was 1.21, and you would get the number of 7.348 meters per second as your result. So you found one of our variables. Now we could find the velocity initial of the y-axis by using the equation A equals velocity final O minus velocity initial over time. And for this case, we're only going to cut the whole progress of the projectile in half to use velocity final as 0 meters per second, because we all know that in the maximum of the parabola, in this case, because it looks like a parabola, whenever you throw an object in the air, it forms a curve, the maximum of the parabola will always be 0 meters per second. So, using this information to our advantage, the final velocity would be 0. The time would be cut in half because we're only using half of the total time. which would be 1.21 divided by 2, 0.605. We already know that acceleration due to gravity is negative 9.8. So we only need to find initial velocity. Times both sides by 0.605. And you would get the grand total of negative 5.929 equals negative initial velocity in the y-axis. But remember, we only need the initial velocity. We don't need the negative, so times both sides by -1. Take off the negative, so we will get the initial velocity for our projectile is 5.929 meters per second. We could find the final velocity by using the same formula as the initial velocity, which would be acceleration equals final velocity minus initial velocity over time. Now, instead of using half the time, we're going to be using the full amount of time, because we're not trying to find just how much was it from here to here. We're trying to find how much it took to get from here all the way here. So if we were to plug in our numbers, we already know what acceleration due to gravity is. So it would be negative 9.8. We already know what our initial velocity is, which is 5.929. We know time, 1.21. And we are trying to find velocity final. Times both sides by 1.21 to get rid of the fraction on the right. Then if you were to do that, you would get negative 11.858 equals velocity final minus 5.929. This is where we're at right now. Plus add 5.929 on both sides to isolate the variable, which is the final velocity. And you will get 17.787 meters per second as our final velocity. That's one more variable down. Knowing our final velocity, we could use the formula of acceleration equals final velocity squared minus velocity initial squared divided by 2d. Now, to find our maximum distance vertically, I'm going to cut the process in which our projectile went in half, so that we could use 0.0 meters per second as its initial velocity and still use our final velocity. It's kind of how we use this method to find our initial velocity in the first place. But now we're doing it to find distance. Plug in the variables, you get negative 9.8. You have negative 17.787 squared, and you have 0 as your velocity initial. Now you multiply both sides by 2d, you get negative 19.6 d equals negative 7.87 squared. This is where we're at right now. pardon my handwriting. This is where we're at right now. Now, if we were to isolate the variable d, we would have to divide both sides of our equation by negative 19.6. So let's do that right now. D equals negative 17.787 squared divided by negative 19.6. Now the result of this would be 17.7 squared divided by negative 19.6. We have a positive number of 16 meters and 0.14, 17, yada yada yada. It's a lot of decimals. But using sig figs, we could round it to 3, so it would be 16.1 meters. And that would be our distance. Our final variable to find is our true initial velocity, a mixture of both horizontal velocity and initial velocity in the y-axis. To find it, we could use this formula. Horizontal velocity equals true initial velocity cosine of 40. Now what 40 represents is the degree in which we launched our projectile, or around the degree in which we launched our projectile. To find our true velocity, we would have to divide both sides by cosine of 40 and end up with v of x divided by cosine of 40 equals initial velocity. And what we get as a result of v of x, which is 7.438 divided by cosine of 40, is, I believe, 9.2, or using sig figs, 9.2. Now, that is an estimate, because remember, it is an estimate of the degrees in which we used. So we had to use our final velocity initial on the y-axis to compare answers. And the formula for that would be final velocity in the y-axis is true initial velocity sine 40. And now to find and isolate the variable of true initial velocity, we simply divide sine both sides, and you get initial velocity in the y-axis divided by sine of 40 equals true initial velocity. Now, initial velocity in the y-axis was found to be 5.929 divided by sine 40, which results in 9.7 meters per second in this formula. Now, because we estimated the angle of our projectile to be around 40 degrees when we launched it, it is only fair that the numbers don't line up, because it is not the true degree in which we launched it. If the degree was exact, then both of these numbers would be the same. But because we know that we estimated the degree, it is okay to assume that the real number the real, true initial velocity is somewhere between 9.2 meters per second and 9.7 meters per second. Thank you.